Good morning, everybody. Sorry about the little technical problems there. We got everything sorted out, hopefully. Seems like most of you guys said you could get in. So if you can give me a green check just so I can figure out everything's going okay and we can get going. Are we doing okay? Everyone seems to be... Yes. All right. Check marks coming in. Good. Perfect. We didn't have math yesterday. It was sad. I didn't know what to do with myself. Hopefully you guys enjoyed I don't know about enjoyed. Hopefully the English essay you guys wrote wasn't the worst thing you've ever done. We'll go with that. Hopefully if I didn't find it too terrifying. There is a few people with no green checks, and Belle is saying hers is freezing. Is anybody else experiencing issues with the live feed or anything like that? It wasn't the worst thing you've ever done. That's good. We'll put that into the plus column then. I think it might just be you, Belle. Everybody else seems to be doing okay. Worst case scenario, we'll just get it uploaded afterwards as quick as we can, and then you can just go from there. Okay. So, seems like most of you guys have checked in, so we're doing good. I want to go on to the second lesson of Unit 7, but if you guys had any questions from the learning guide from the previous day's work, remember on Thursday's class, seems like so long ago, we were looking at solving systems of equations by graphing them. So we would, instead of be given one line, we'd be given two lines, and then we need to figure out where those lines intersected on a graph, and we'll then be able to identify the solution. That's what we call it. So where the two lines cross, we call it the solution. Avery's asking, is this learning guide due this week? Yeah, there's only 3 sections of this unit, 3 lessons. And we're going to do lesson 2 today. We'll do lesson 3 tomorrow, and that's really it. And then Thursday will kind of be like a review. And if you can get the learning guide submitted on Thursday or Friday, that would be great. And I can get the test password out to you guys for this unit. Or I'm going to try checking my email maybe on Monday to see if anybody had submitted something. And maybe I'll do like Monday this week, Monday or the following week. So I'll check my messages a couple times over the break. I can't guarantee you I'll be looking at my work email over the break, but I don't want you guys to not be able to write this test because you've submitted something. So if you can get this unit submitted, it's only 3 lessons. The learning guide's not terribly long. If you can get it submitted Thursday or Friday, then you can just write the test whenever you want. I mean, it would be, in a perfect world, you get it submitted Thursday afternoon, write the test on Friday, and then be all caught up for the entire winter break. But that's probably not a realistic scenario for a lot of us. So take it for what it's worth. If I had my way, I would have everyone submitted, caught up to the end of Unit 7 by the end of the day on Friday, and then you wouldn't have to worry about anything moving forward. I have pre-recorded some of Unit 8's lessons, so I'm gonna open up Unit 8 on maybe Thursday or Friday, and if you want to look through it, you can, and it'll be there if you want to kind of look at it. And some of you guys are really good at it. It's trigonometry, so sine ratio, tangent ratio, cosine ratio. And you can do it over the break, but I don't want you to have to worry about doing math or any work over the break. I want you to just kind of relax, spend time with family, friends, whatever you want to do. So page 2, 6B from the learning guide. Page 2, 6B. All right, so we're given 2 lines, and then we're asked to figure out the solution to the system. So where do the lines intersect one another? Now, the first equation I have here is in, it's not in any form that we know. We didn't call this standard form or general form. It's just kind of a line. So if I can get it into slope-intercept form, y is mx plus b. Once I get it there, I can plot it. And then I'm going to do the same thing with the second equation here. So let's look at the first equation. 3x minus 5y is negative 10. Now I'm going to try to get y by itself. So I'm going to add 5y to both sides. Now I'm adding 5y to make it positive on the right side because I want to get y equals. So I have 3x, my y's go away here. I get 5y minus 10. Add 10 to both sides. Now I have 3x plus 10 is 5y. Divide everything by 5. I'm going to do all three terms by 5 just because that's going to work out a little bit more nicely. So I get 3 over 5 times x plus 2 is y. So I can plot that now. My y-intercept's plus 2. Maybe let's pick a color that's not black. Let's go with blue. So I have plus 2 as my y-intercept, and my slope is 3. 1, 2, 3. And my rise 3, my run is 5. So 1, 2, 3, 4, and 5. There we go. So now I have 2 points. I can connect with a line. And I want to draw this line as accurately as possible because I'm trying to identify where these two lines are going to intersect. So the more accurate I am with my line, the more accurate my solution is going to be. The second equation I have here is y plus 1 equals 0. And this is maybe where you got a little bit caught up, because this is a bit of a strange one. If I subtract 1 from both sides, I get y is equal to negative 1. So this is one of these strange lines where I don't have really any information. I don't have a slope. If this was in y is mx plus b form, I only really have a y-intercept, negative 1. So I'm going to find negative 1 on my y-intercept here. And it really doesn't matter what x is. Y is always going to be negative 1. So it doesn't matter if x is over here, or x is over here, or x is right there. I have a horizontal line. Slope of 0. There's no slope there, so the slope is 0. And I can plot that line. It's just a horizontal line at y is negative 1. Now, in order to answer this question, I need to figure out where my points intersect. And I can see that that's happening right here. And I could write solution to this system is happening at negative 1, 2, 3, 4. So negative 4, negative 1. That's the solution to this system. That's where those two lines intersect. So that's how you do it. Perhaps the difficult part of this question was because that second equation was just y is negative 1. That's a horizontal line, and that can be a bit tricky. So I'll leave it at that. I know I mentioned this last day, these lessons are really long because I was trying to kind of put 2 lessons together into one so we can finish before the break and just the way that the course was laid out. So I'm going to get through as much of lesson 2 as I can. There's kind of 2 lessons here. I'm going to do as many as possible, and then we'll just kind of set you guys free into the world of math to get some of this stuff done. So, Taylor, you got another question? I'll try to get to that one after, but I don't know if I'll have enough time because we only have an hour today. So I might have to do that one tomorrow. And there's always Thursday's class, which will just be an hour of questions. So anything that I didn't get to before then, we can do then. All right, so the title of today's lesson is Solving by Elimination. And the idea here is that when we're solving a system of equations, we have 2 lines. In grade 10, we are just dealing with lines, straight lines. And where the lines intersect is our solution. So we looked last day at graphing our lines, putting them on a graph, and figuring out where they crossed. So that's one way to solve a system of equations. There's another way we're going to look at today. And this way is basically adding our equations together, kind of like when you learn to add, and I don't even know what grade you learn to add, probably like 3, maybe 2, I don't know. We're going to kind of go back to that sort of idea, adding and subtracting, and we're going to look at this. And generally speaking, this is the method that students like the most. If you're just given a choice to do whatever method you want, this is usually the one I pick, so take that for what it's worth. Adding or subtracting two equations in a linear system produces equivalent linear systems. We use this property to solve a linear system by first eliminating one variable by adding or subtracting. The two equations. This is called solving by elimination. And like I said, this is probably, if given a choice of solving equations, this is probably the method most students will choose. All right, so we're given two equations, 5x plus y minus 13, and 2x plus y is negative 1. Now, on a test or something, it's likely that it will just say solve this system. So you're trying to find the point where those two lines intersect. If you want to draw a graph, you can. There's nothing wrong with that. And sometimes it's a good way to check your answer, but there's other ways. So without graphing, how do we solve this system or find a point that satisfies both equations, or where do those two lines cross? Those are all kind of asking the same thing. So since the coefficients of y are equal, we can eliminate y by subtracting the equations. So then solve for the remaining variable. So when we're talking about the coefficients of y, we're talking about the number that's in front of y. So in the first equation, there's nothing in front of the y, so we know there's a 1 there. In the second equation, there's nothing in front of it as well, so we know there's a 1 there. So the coefficient of the number in front of the y is the same for both. So this is what we're going to do. I'm just going to rewrite it like this. 5x plus y is equal to negative 13. And remember back when you were just learning to add or subtract, you lined everything up vertically. So I'm going to put all of my x's on top of my x's. And I'm going to put my y's on top of my y's. And I'm going to put my negative 13 on top of my negative 1, or just the constant or the number. And we're lining everything up vertically. Just kind of like when you're adding or subtracting, you line everything in the tenths column up, you line everything in the hundredths column up. Same idea here. So what we're going to do is this. I'm going to draw a line like we're adding or subtracting in elementary school, and I'm going to put subtraction in front of this thing. So what we're going to do is literally subtract my two equations, which may seem kind of weird. So I'm just going to work across each column. So if you want to think of each of these things as being in a column, you could do that if you wanted. You don't have to draw these columns in, but that's the kind of idea I'm talking about here. All right, so what I'm going to do is I'm going to take my 5x here, and I'm going to subtract 2x. So I'm going 5x minus 2x. So what do I end up with for my x's? So 5x minus 2x gives me 3x. This is what needs to happen. The second one here, I have y minus y. So if I have a y and I take a y away, how many y's do I have? Well, I don't have any y's left. So I could write 0y, but I'm not going to just because they're going away. And then over here I have negative 13 minus negative 1. So subtracting a negative is kind of like adding. So I have negative 13 plus 1 gives me negative 12. Now the whole idea here, the reason I added these equations or subtracted them, I should say, is so I could get rid of one of my variables. When I have lines, I have x's and y's. If I have both an x and a y in an equation, I can't figure out what either x or y is at any time. But if I can eliminate one of my variables, in this case y, I can figure out what x is. Then once I know x, I can plug it back into the equation to figure out what y is. Remember, all of this is just looking at where these two lines crossing. So instead of drawing a graph, today we're going to just do it algebraically. So we're not going to do any graphing today. All right, so I have an equation here. I have 3x is equal to negative 12. And I can just solve for x. So if you think of it this way, I have 3x is equal to negative 12. I'm going to divide both sides by 3. And I'm going to end up with x is equal to negative 4. So that's the x coordinate that will satisfy both of the equations. So determine the value of y being x negative 4 in either of the original equations. Doesn't matter which one. Remember, the point we're finding should satisfy both equations, so the first and the second equation. It doesn't matter which one we pick. We have 5x plus y is 13 on the top, so maybe let's try that one. So I'm going to take one of my original equations, 5x plus y is equal to negative 13. That's what I started with from up above here. And I'm just going to substitute x is negative 4 into the equation. All right, so I'm going to go 5. And then everywhere there's an x, I'm going to put in a negative 4. And because I've substituted a value in for x, the only variable I have left is y. So now I'm going to solve for y. So I get 5 times negative 4 is negative 20. Plus y is negative 13. I'm going to add 20 to both sides. I'm going to get y is equal to 7. All right, so what I've just done is I've discovered my x value here is negative 4, and I've discovered the y value is 7. So that means my solution is negative 4, 7. That is the point that satisfies both of these equations. Now, one good thing about this section is we can always get this point, and then we can substitute it back into each equation to see if each equation becomes true. So we can check, essentially, whether we did it right. So I'm just going to leave that there. I'm going to try to fit a little check in here. So my first equation was 5x plus y is negative 13. I said my x was negative 4 and my y is 7. 5 times 4 is negative 20 plus 7 is negative 13. And I end up with negative 13 is equal to negative 13. So that was my first equation. It satisfies it. That's good. My second equation was 2x plus y is negative 1. So I'll start with that. 2x plus y is negative 1. I'm going to put in, for my x, negative 4. For my y, I'm going to put in 7. 2 times negative 4 is negative 8. Plus 7 is negative 1. Is that right? Yes, negative 1 equals negative 1. So, yep, it satisfies both equations. So that point is the one that satisfies both equations. That is my solution. What if you pick the other equation to substitute? That's fine. You're going to end up with the same thing, Taylor, because the point you're picking actually needs to work for both equations. So it doesn't matter which one you choose. You would have ended up with y is equal to 7 had you substituted x as negative 4 into either one of the equations. So it didn't matter which one you picked. You can verify it for yourself. The check's just kind of a nice little thing you can do at the end just to make sure that everything went according to plan. Sometimes it will work out, sometimes it won't. If you get something goofy like negative 1 is 2, you're like, oh no, I picked the wrong point or I solved for the wrong point. There's some error or something that you need to go back and address. All right, So let's look at another example, the exact same process, except we have two different equations now. So we have 2x plus 4y is negative 4, and then 4x minus 5y is 5. So the good thing about the first question that we did was the number in front of our y was the same. It was 1. But now there's no coefficient that's the same in front of my x's and my y's. So we have a bit of a problem here, which isn't really a problem. So what we do is we identify that no terms have equal coefficients. That's the first thing. There's no number in front of both the x's or both the y's that's the same. That's okay. So what we can do is look for a set of coefficients with one variable that could be multiplied by some number to become the same as the other one. Kind of a strange idea, but really when we have an equation, we can multiply both sides of the equation by any number we want, and that's fine. It's just doubling the equation or tripling it or quadrupling it or whatever number we want to multiply by. So the most efficient option is to make in this case, we're going to make the x terms alike. And by doing that, we can then eliminate a variable. So there's a little hint here. I don't know if the hint's super obvious or not, but the least common multiple, remember we talked a little bit about least common multiple. Least common multiple between the two x terms is going to be 4x. So if we look at our equations, I call this one equation 1 and this one equation 2. If I multiply equation number 1 by the number 2, we're going to get a new system of equations. All right, so I have equation 1 is 2x plus 4y is negative 4. And I have equation number 2 is negative 4x minus 5y is equal to 5. So what I'm going to do is take everything in equation number 1. I'm going to multiply everything by 2. So equation 1 is going to look like 4x plus 8y is negative 8. So once I've multiplied by 2, I end up with that. And now my x terms are the same, which is what I really wanted to happen. So now that the coefficients of x are equal but opposite, we can eliminate x by adding the equations and then solve for the remaining variable. So that's what we're going to do. We're going to rewrite the two equations vertically, so the x's are above the x's, the y's are above the y's, and then that extra number, the constants, are above each other. So I'm going to start with my equation here, 4x plus 8y is equal to negative 8. And then I'm going to have my second equation, which was 4x minus 5y is equal to 5. What I'm going to do is pretend I'm in grade 2 again. I'm going to write everything on top of one another, and I'm going to add these two equations together. And the reason we're adding this time is because the number in front of the x was negative 4 and positive 4. So if I add negative 4 to positive 4, I end up with 0. So my x goes away. I'm left with y. I can solve for y. Once I have y, I can put it back into the equation and then get the value. So looking here, 4x minus 4x is going to give me 0, but I don't need to write it, so I'm just going to ignore it. And I'm going to go 8y plus negative 5y. So I have 8y's. I'm going to add negative 5 to my 8. So how many y's do I have? Well, 8 plus negative 5 is going to give me 3y's. And then negative 8 plus 5 gives me negative 3. I have 3y is equal to negative 3. I'm going to divide both sides by 3, and I'm going to end up with y is equal to negative 1. So I know half of my solution. I know what the y value is going to equal. Y is negative 1. So I can now take that y value and plug it into either one of my equations. Doesn't matter which one. Taylor asked, well, what if you substitute into the other one? It doesn't matter which one I pick. So you can pick the first one. We picked the first one the first time. Let's pick the second one this time. So we have negative 4x minus 5y equals 5. So we're going to determine the x value by substituting y as negative 1 in either of the original equations. And I said to Taylor, we're going to do the second one this time instead of the first one. Negative 4x minus 5y is 5. And we're going to plug in this y is negative 1 in for anywhere there's a y. So I get negative 4x minus 5 times negative 1. So all I'm doing is substituting negative 1 in for y. And then I'm going to solve for x. So I have negative 4x. Negative 5 times 1 is positive 5 equals 5. I'm going to subtract 5 from both sides. Gives me negative 4x is equal to 0. And x is 0 divided by negative 4, or just 0. So there you go. My x term is 0. You're thinking, oh no, it's 0. It's not like a number. Well, that's fine. There's nothing wrong with 0. 0 is a point on the x-axis. It just happens to be in the middle. So there's nothing wrong with getting 0. Alex, I'm just seeing your question here. How can you calculate the slope of m when given x? Basically, when we have the slope, we can't find the slope unless we know the x and the y coordinate. So there's basically three things. You have an x coordinate, you have a y coordinate, and you have the slope. You need to know two things in order to get the third. So if you know the x and y, you can find the slope. If you know the slope and the y, you can find the x. If you know the slope and the x, you can find the y. So I don't know if that answers your question. You can't unless you know two of the three things. But we're not talking about slope today, so I'm hoping that's coming from something we've done before. All right, so the solution to the system is x is 0, y is negative 1. And that is my answer. And that's it. And I can check, and I encourage you to check in order to save perhaps a little bit of time. I'm not going to check, and that's a really bad habit, so don't do that. Always check, but I just want to do the next question. So that is the correct answer. We have 0, negative 1. So if we had plotted both those lines on a graph, we would have found that they cross one another at 0, negative 1. That's just where the lines cross. We found out where the lines crossed using just algebra. We didn't have to plot it. We didn't have to draw a graph. We didn't have to wonder if our lines were straight or if we were using the right slopes or anything like that. So we can just use maybe the information we're given to just find the answer in another way. Let's look at the third example. This one's a little bit different again. You can see that we're starting with two equations. They look kind of similar, but the number in front of the x isn't the same. The number in front of the y isn't the same. So we can't just add or subtract these equations. It's just not going to work. Now, in the previous example, I said, I can multiply one of those equations by 2, and then the x term is going to be the same. Is there an equation here we can multiply by something that will make our x or y terms the same? The problem here is this. If I multiply this 3 by, let's say, 2, that's going to give me a 6. That's not going to be a 5, so that's not going to work. I can't multiply the 5 by anything to give me a 3, so that's not going to work. And then same here. If I multiply this 4 by, let's say, 2, I get 8, which is bigger than 6 already. And I can't multiply 6 by any integer value to give me 4. So I've run into a bit of a problem. Nothing that we can't handle. We have equations 1 and 2. So the trick here is instead of multiplying one of my equations by a number, I'm going to multiply both of my equations by a number, and the number doesn't have to be the same for either equation. So let's take a look at what this is going to be. We have some notes here. No terms have equal coefficients. Look for a set of coefficients of one variable that could be made equal by multiplying one or more equations by a constant. So we're going to just look at the x terms. You could do the y terms if you want, but I'm just going to look at the x terms for now. Their least common multiple is 15. So 3 and 5, the multiple that's closest to each of those is 15. So to make these terms equal, we're going to multiply the first equation by the number 5 and multiply the second equation by the number 3. And then we're going to subtract, because they're both going to be positive, to figure out what that y term is going to look like. So what I'm going to do is I'm going to rewrite the equations. So my first equation was 3x minus 4y is equal to 7. My second equation was 5x minus 6y is 8. And I said I'm going to multiply my first equation by 5, and I'm going to multiply my second equation by 3. So what's that going to look like? Here we go. 5 times 3 is 15x. 5 times 4 is negative 20y. And then 5 times 7 is 35. So that's the first equation multiplied by 5. The second equation is multiplied by 3. So 3 times 5 is 15x. 3 times 6 is negative 18y. And 3 times 8 is going to give us 24. So at this point, we can take these two equations and subtract them because I have 15 in front of both of my x terms, which is kind of nice. That's what I was hoping to do. So I'm going to go 15 minus 15x and get 0 x's. I'm not going to write it down because it's just going to confuse me. This is where the signs get a bit tricky. I have negative 20y minus negative 18. So it's like negative 20 plus 18 because I'm subtracting negative 18. So I'm going to end up with negative 2y out of those two. And then I'm going to go 35 minus 24. And I'm going to end up with 11. So doing a little math, dividing both sides by negative 2, I'm going to get negative 11 over 2 is y. And that's a bit of a strange one. Normally these things work out nicely, but we're just going to go with it. That's what we got. We're just going to have confidence in our answer. It's negative 11 over 2. The other two worked out nicely. This one might not. So it's okay. Be confident in what you get. So what we need to do now is substitute y is negative 11 over 2 into either equation. It doesn't matter, first or second. The first question we did the first equation, the second question we did the second equation. Maybe we'll go back to the first equation this time. So we have 3x minus 4y is 7. And I'm going to substitute negative 11 over 2 in for y. So I'm going to get 3x minus 4. And I'm going to put in negative 11 divided by 2 in for the y. Now the only variable I have left is x. So I'm going to solve for x. So nothing's happening here. I have 3x. 4 times 11 is 44 divided by 2 is going to give me 22. I could write it as negative 44 over 2 if I wanted, or positive because I have two negatives. So I have 3x plus 22 is 7. I'm going to subtract 22 from both sides. I end up with 3x 7 minus 22 is negative 15. Divide both sides by 3. And I end up with x is equal to negative 5. So my solution is my x term, negative 5, and my y term, which was negative 11 over 2. That would be the answer to the system of equations. Two equations, if I were to draw a graph, they would both intersect at negative 5, negative 11 over 2. I could check by substituting my solution into both equations, making sure the left side equals the right side. And I encourage you to check. Again, I only have 10 minutes, so I want to just do one question off the second set of questions here, the second set of pages. So before we get there, how are we feeling about this? This elimination stuff. How do we feel? We got thumbs up, thumbs down, green check, red X, confused, halfway, in between. What do we think? General feeling, it's okay. It's definitely one of these things where you need to try a few of them and see how they kind of work out. One person's awake out there in math land, just Taylor. Taylor, private tutor today. Thumbs up from Ava, perfect. It's good. And like I said, once you look at a few questions and you add or subtract the equations, it should work out and you'll kind of figure it out. The process doesn't change though, it's the same thing. Maybe the hardest thing is figuring out what the two equations need to be, what you could pick an X or the Y or whatever you want. Taylor's good too? All right, if Taylor's good, we're moving on. Now, this sort of, the questions here, I'd like to come back and do a few more of them, but we might not have time. So there's always a question or two that ends up looking like this, especially on the provincial. Basically, it just gives you a bunch of information, and you need to take that information and turn it into an equation. And then once you have the two equations, you need to figure out if you can determine a solution from the two equations. So they can be really easy or they can be really hard. You just kind of hope that you get an easy one, but they can be hard. Let's just maybe look at the equations or the information we're given and just see if we can do it kind of step at a time. So using a diagram to model a situation. Create a linear system to model the situation. So you'd be given something like this here. The perimeter of a flag is 16 feet. The length of the flag is 2 feet longer than its width. So essentially you're kind of trying to figure out how big the flag is in terms of length and width, but it doesn't give you any direct information. It's kind of indirect information. It doesn't say the length is. Unfortunately, it says the length is 2 feet longer than the width, but you have no idea what the width is. So let's draw a rectangle. This is my rectangle. I have a width, I have a length, and I have a length. So there is my rectangle. We call this a system of linear equations, and it requires two or more equations. The idea is for every variable you have, in this case we have two, we have length and width, you're going to need an equation. So if I had three variables, length, width, and height, I'd need three equations. If I had 5 variables, I'd need 5 equations. So just the beauty of math is if you have two variables, x and y, in this case length and width, you're going to have 2 equations to solve the system. And this just extends right on through to math all the way to the end of university. This is really true. So let's try to figure out a couple of equations from the information we're given. The first thing we're given is the perimeter is 16. So that's an important piece of information. I can calculate the perimeter. So if I took the length of one side and added it to the length of the other side and added it to the width and added it to the width, I'd end up with 16. Now, writing that kind of like that looks a little goofy. So I'm going to write it as 2 length plus 2 width is equal to 16. So these are essentially the same equations. So there's one equation. Now if we go back to the question, the second thing it says the length is 2 feet longer than its width. So we have length is 2 feet longer than width. How could I write that as an equation? There's two different ways you could write it. You could write it as the length minus 2 is equal to the width, or you could write it as the length is equal to the width plus 2. Either one of those is fine. They're the same thing, just written two different ways. So it just depends on how your brain works. If you read the question, the length is 2 feet longer than the width. So you think, okay, length minus 2 is the width. So you come up with this one. Or you could think, okay, length is width plus 2, and you'd come up with that one. It doesn't matter. They're both stating the same thing. So our linear system is going to be 2 times the length plus 2 times the width is equal to 16. There's my first equation. My second equation is going to be, I'll pick the second one here, length is width plus 2. I kind of like not having negative signs, so I'm going to pick that second one. All right, so we have a system of equations to model what information we've been given. So the next part of the question, it says, Denise has determined the flag is 5 feet long and 3 feet wide. It wants us to check if this is correct. So basically we're given information to check to see if our system is the correct system. So instead of asking us to solve the system, it gives us a solution, and it says, is this a possible solution to the system you created? So the idea here is that we're not checking to find the solution. They're giving us a solution. They're checking to see if the system we created was the right system. So it's telling us that the length is 5 and the width is 3. So what I'm going to do is take my first equation, 2L plus 2 width is 16, and I'm going to plug in the information I'm given. So I'm going to go 2 times 5 plus 2 times 3 is 16. I'm checking. So 2 and 5 gives me 10, 2 and 3 gives me 6, and I get 16 is 16. So that works. What about the second equation? I'm going to have length is width plus 2. The length is 5. The width is 3 plus 2. 5 is equal to 5. So that worked. Awesome. It's nice when something works out like that. So Denise was correct. That's nice. A set of linear equations considered together to form a system of linear equations. A system of linear equations is often referred to as a linear system. A solution of a linear system is a pair of values of the variables that satisfies or satisfy both equations. So exactly the same thing we were doing from last day. We have two equations, they're lines. We want to figure out where those lines cross. That's the answer. That's what we're trying to find. Last day, we plotted it on a graph. Today, we've said, okay, what if we don't plot it? We can just use algebra to figure out what x and y is. So if you have two equations and two variables, you can solve it to figure out a solution. Now, there's about 5 or 10 minutes left. There's two additional examples in the lesson here. So what I'm going to do is I'm going to help you set those up, and then you're going to look at the learning guide and things like that. The hardest part is setting it up. So we can for sure get to the next one here. I'm not sure if we'll get to example 3. So we can use a table to kind of organize our ideas and solve these systems. So create a linear system to model the situation. In Calgary, a school raised $195 by collecting 3,000 items for recycling. Received 5% for each can, 20 cents for each plastic bottle. We're going to try to solve the system, or model the system, I should say. So the first thing we need to do is we have cans and we have bottles. So what we're going to do is let C be the number of cans, because C stands for cans. And we're going to let B equal the number of bottles. All right. So we're given that, and then we're given some information as well. So refund for item. Instead of doing everything in cents, it'd probably be easier to do everything in dollars, because we have $195 in the question, and then we have each can is 5 cents, each bottle is 20 cents. We don't want to convert $195 into cents. It would just be kind of weird. So what I'll do is I'm going to say each can is $0 or $0.05. And each bottle is $0.20. So writing down the total here doesn't necessarily make sense, so we'll leave that blank for now. The number of items. So for cans we have C, and for bottles we have B. We don't know how many cans we have, we don't know how many bottles we have, but we do know something about the total number of cans and bottles. It says the number of cans plus the number of bottles equals 3,000. So they collected 3,000 things. So that was given in the question. The other thing we have in the question is that there's this $195. So if we took each can and we multiplied it by 0.05 times C, and if we took 0.20 and multiplied it by B, so 5 cents for every can, 20 cents for every bottle, we would end up with $195. So this is just a way of organizing the information in this table. You probably could have looked at the information and maybe come up with these equations on your own. Sometimes the table is just kind of nice because it helps us organize our thoughts. So the third column can be represented by taking the number of cans. This is just the information from the question. So we know that if we take the number of cans and we add the number of bottles to it, we end up with 3,000 because we collected 3,000 items. The other thing we're given is the fourth column, 0.05 or 5 cents times the number of each cans plus 20 cents times the number of bottles is going to end up giving us 195. So essentially we have a system of linear equations, 1 and 2 equations that we can then solve. So we could rewrite the equations here if we wanted, and then we could, just like the previous question, we could check this 2,700 and 300 for C and B, and then solve the system and check our equations to make sure it's true. I don't have time for that today, so I'm just going to leave it there. I think there's one other question on the back. We have riverboat, and then the practice. Don't worry about doing the practice. So we're just going to kind of ignore the practice. Let's look at the learning guide and see kind of where we're up to now with lesson 2 here. So we know we can do page 3 now. That was last day. Solving by elimination is what we've just done. So there you go, solve the system by elimination. It's important because we're going to learn 3 different ways to solve equations that if it asks you to solve by elimination, you have to solve by elimination. Just for the learning guide. On a test, when it says solve a system of equations, you can do whatever way you want. But for a learning guide, I need to be able to verify that you can solve by substitution, you can solve by elimination, and you can solve by graphing. So if the learning guide says solve by elimination, solve by elimination. So there's 3, 4 solving by elimination questions. And that's kind of it. So that's lesson 2, which is on page 5 here. Just a few questions. So next time we're going to do, or tomorrow we're going to do solving by substitution. And then we'll look at some more word problems after tomorrow's class. So hopefully I have time to do a couple more word problems next day. And that's it. So really super short section, 3 lessons. We're going to do some more word problems next day because I know they can be really hard. I only got to 2 of the 3, so we'll look at a few more of them. I'm just going to leave it there. So hopefully that's good. I don't really have much to say. You guys have a movie on Thursday if you want to come see In the Heart of the Sea on the west side. You can come do that. I think math has actually moved up to 9:30 on Thursday, 9:30 to 10:30, so you guys will have time to make it to the theater on time. So just take note of that on the website. I think it's listed as that now. That's really it. So tomorrow we're going to look at the 3rd lesson. Thursday is going to be a review, and we're done for the break. Crazy. Taylor, I know you had another question off of page 3. I'll get to that tomorrow, hopefully. We have a little bit more time tomorrow morning. And that's it. So hopefully you guys have a chance to look at these because they can get tricky, but you know the process is there. And hopefully you'll have some questions next day. So thanks, and we'll see you in class tomorrow.